Dear students, welcome back to another session of the Bridge course. In my last session, I had explained how to find the logarithm of a number. Just very quickly, let's recall. The logarithmic of a number, for example, log of 2 or 2.000. We can find it using logarithmic table. And when we find the log of a number, we get two parts. One is a characteristic, which is 0 in this case. And then we get mantissa, which we can find using the logarithmic table, and we get that as a 3010. So this is the number, and this is the value of this number. So this is the number given, and this is the value, the logarithmic value. Similarly, the log of 0.2000, we get it as bar 1.3010. So what is the difference here? So this is a log of a number which is greater than 1. This is a log of a number which is lesser than 1. When the log of a number is greater than 1, the characteristic is always positive, and when the log of a number is lesser than 1, the characteristic is negative. The mantissa is always positive. So this is what we have learnt in the previous session. Now, if you are given the value, then how to find the number? So this is reverse of the logarithm, so which is called anti-logarithm. So while finding the anti-logarithm, we come across two types of values. One, a value having positive characteristic, and the value having negative characteristic. And similar to the logarithmic table, so we have anti-logarithmic table, which you can see on your screen. So I'm going to explain now how to find the anti-logarithmic of the two types of values. So I'm going to classify here into two categories. The first one, antilog, we write it as a dot log of a value having positive characteristic, and the mantissa I'm going to write it as 1021, like this. So I want to find the anti-logarithmic of this value, which gives me a number. So what is the method involved? To find the anti-logarithmic of a number, first you leave, so this is the characteristic and this is the mantissa part, okay. So leave the characteristic for time being and take only the mantissa part, and split this mantissa part into three, mantissa into three parts. First 2 digit, and then 1, and then 1. So it is 0.10 to 1. And now refer the anti-logarithm table. 0.10, which is here. Then the next digit is 2. So that you have to search in the first row, which is here. So where do these two numbers intersect? 0.10 and then 2, they intersect here. It's 1265. So which I'm going to write here, 1265. The next digit is 1. So which you have to search in the mean difference. The mean difference 1 is here, 1. And that intersect with the initial number at 0. So that is to be added. So 12650 will give you 1265 only. So do write that number here after adding 1265. After that, the rule is this. After writing this 4 digit, you write decimal point always after first digit. Keep this in mind. Put the decimal point after first digit only. And then you multiply by 10 raised to the power, and that power must be the characteristic, which is 0. But what is 10 to the power 0? It is 1. So therefore, the final answer is 1.265. So therefore, now we see that the anti-logarithmic of 0.1021 is 1.265. So I'll give you one more number, anti-log of 2.0536. So I want to find the anti-log of 2.0536. 2 is the characteristic, leave aside. Now consider the mantissa. Again, from the decimal point, take first 2 digit, which is 05, next, and then next. That means that 4 digit, if you have to split into 3 parts. 2 digit, 1 digit, and then 1. Okay? 0.0536. Now where is 0.05? It's here, 0.05. 3, which is here. Now where do this 0.05 and 3 intersect? At 1130. So make a note of it, 1130. After that, the next digit is 6. And that you have to search from the mean difference, which is here, 6. So, see this 0.05 and then 6, they intersect at 1. See here. Sorry, not at 1, it is at 2. Okay? So, 0.05 and that 6 intersect at 2. So, therefore, 2 is the mean difference, which is to be added at the end, and that will give you 1132. So, write that first, 1132. After that, so where you have to write the decimal point, always after the first digit, which is here. Okay, multiply by what? 10 to the power, that power has to be this, which is 2. What is 10 power 2? It's 100. 100 into 1.132 is nothing but 113.2. So that's the antilog of 2.0536. So I'll give you one more number from the same table. Antilog of, let's take 10.0311. 10.0311. So first characteristics, so that has to be left as it is. Later we are going to use it in writing the power here. So you always start from the mantissa part. So always how many digits to be taken first? 2 digit. 0.0311. 0.0311. 0.03 is here. 1 is here. They intersect at 1074. 1074. After that, there is a 1, which is the mean difference, which is 0. See, here it is. It's a 0. So therefore, the digit remained the same, 1074. 1074. Correct? Okay. Now, tell me what you are supposed to do. Write the decimal point. Where? After the first digit. What next? Multiply by 10 raised to the power of that characteristic, which is 10. So this is the answer. We don't simplify this because this is a large number. See here and all, so this 10 raised to the power was a small number, but this 10 to the power 10, it's a huge number. So we don't multiply and then write it. So we leave it as it is. So I hope you understood how to find the anti-log of a number having positive characteristic. Okay. So let me give another set of example where the characteristic is not positive, but the characteristic is negative. So these are the only 2 cases that you come across. So I'm going to give example now. What if the characteristic is negative? So antilog, I will give you bar 1, bar, negative characteristic. The mantissa is 0.4026. So what is the rule in this case? The rule remains the same. Take the first 2 digit after the decimal point, that's 2 digit, and then 1, and then 1. 0.4026. Okay. Where is 0.40? Which is here. 0.40. Next digit is 2. So 0.40 and the 2, they intersect at 2523. So write that 2523. Then what is the next digit? It is 6. So 0.40, 6 you have to refer from the mean difference. The mean difference 6 is here, and the intersection of that initial number and that mean difference, that comes out to be 4. Add that here at the end, so you will get 2527. 2527. Okay, right. What next? So we have to place the decimal or write the decimal after first digit. Okay, and then multiplied by 10 raised to the power. This is a negative characteristic, so therefore you have to write it as minus 1. What is the meaning of 10 to the power minus 1? Meaning of 10 to the power minus 1 is nothing but dividing by 10. So therefore you can write 2.527 divided by 10 will give you 0.2527. So I'll give you one more example, that is antilog of 3 bar 0.4444. 3 bar 0.4444. So consider 2 digit first, and then single digit, and then one more digit. So when you consider 4 digit like this, so 0.44 is here, 0.44. Then 4, which is here, 2780. So consider 2780. And then 4 from the mean difference, which is here. And that 4 mean difference gives a value which is 3. And add that 3 here. So you will get 2783. 2783. After that, write the decimal, after the first digit. And then multiplied by 10 raised to the power minus 3. Minus 3. So this is the antilog of bar 34444. You can even further simplify if required. Dividing this by 1000 is nothing but 0.002783 is the answer. So one more example, antilog of bar 5.3621. So consider 2 digit first, 0.36, which is here, 0.36. And then 2, which is here, that's 0.36, and then 2 will give you 0.23, that's 2301. The next digit is 1. So for which find the value from the mean difference here, which is 1, and then that coincides with 1, and then add that here at the end, that will give you 2302. 2302. So the rule is to write the decimal point after the first digit and then multiply by 10 raised to the power minus 5. So this is how one can find the antilog of a number and the antilog of two types of number. Which are the two types of number? One number having positive characteristic, the other number having negative characteristic. So you have learnt how to find the log of a number. You have learnt how to find antilogarithmic of a number. And in my next session, I will tell you what is the application of logarithm and antilogarithm. Thank you.